Hi everyone, today I have a really interesting problem for you and we're going to be looking at inequalities and maxima-minima, and I'm going to try and reduce my use of calculus over here. We're only going to look at single variate calculus over here, but a little bit of calculus will be imperative. You need to know a little bit about maxima and minima function and how that works, the derivative test essentially, but we're going to use as less calculus as possible while trying to approach this. So let's begin. This is the problem number 2 from the part B of the CMI entrance exam in 2015. And in this video, we essentially need to we really need to learn how to prove inequalities with certain restrictions, right? And then you're going to see how to find the maxima minima of a function in a given interval. Then we have certain book suggestions for ISI and CMI. And then at the end, we have a similar but challenging problem.
This video is sponsored by Cheenta.com. Since 2010, Cheenta has trained thousands of students from all around the world in mathematical Olympiads, physics Olympiads, computer science and informatics Olympiads, ISI CMI entrances, and research projects for school and college students.
Okay, so this is what is given to us, right? Let PQR be real numbers such that P square plus Q square plus R square is equal to 1. And then we need to prove this given inequality. And after that, we need to find the smallest possible value of 3p square q plus 3p square r plus 2q cube plus 2r cube, and also specify when it occurs. So like we need to give certain values of p, q, r, where this is assuming its minimum possible value, right? So how should we start this? How shall we progress with this? So this is the given quantity to us, right? 3p square q plus 3p square r plus 2q cube plus 2r cube. Now if I just try and somehow factorize this, I'll get 3p square times q plus r over here, and over here I'll get 2 times q cube plus r cube, and this is nothing but the simple factorization of a cube plus b cube, which is a plus b, a square plus b square minus ab. Great. Now I can take q plus r common, so this essentially leaves us with 3p square plus 2q square plus 2r square minus 2q times r. Now that's actually great because now I can make a slight observation. I can write this term as thrice of p square plus q square plus r square minus q square plus r square plus 2qr. Right? Can I do that? That's great. Now, why did I do that? Well, if you look at the question, they had given us this condition that p square plus q square plus r square is equal to 1. Right? So, if I put this into this, I'll get q plus r times 3 minus q plus r whole square. Right? And we need to maximize or minimize this. So, if I take q plus r is equal to x, I get a function f of x is equal to 3 into 3 minus x squared. Right, so this x square should be actually not here. It's something like this, right? So this is f of x is nothing but 3 minus x squared times x, right? Or in other words, I can just write f of x as 3x minus x cubed. Okay, now how do we deal with this? Now, what we're going to do is we're going to see what values x can take in the restriction or in the constraint that p square plus q square plus r square is equal to 1. Let's see what values of x we can assume by this, or we can get by this. Now, we have this this quantity that q square plus r square is greater than or equal to 2qr. Where does this come from? Essentially, q minus r whole square is greater than or equal to 0. And when you expand this, you get this, right? Okay, so we have this quantity 2qr is less than or equal to q square plus r square, right? And it can be also received from the quadratic mean and geometric mean. But okay, we got this quantity. Now, if I just add plus q square plus r square on both sides, I'll get this will be less than or equal to 2 times q square plus r square, right? And this will nothing be q plus r whole square, which is less than or equal to, this will essentially be less than or equal to 2. Why? Because q square plus r square will obviously be less than p square plus q square plus r square, less than or equal to actually. If p is equal to 0, then it will be equal to, and p square plus q square plus r square is 1, so 1 times 2 is equal to 2. So essentially we get this inequality for this q plus r. Q plus r essentially lies between root 2 and minus root 2. Now that's great. So we kind of got a range of x, right? So x essentially belongs to root 2 minus root 2 to root 2, right? In the closed interval. Okay, that's perfect. So now all we really need to do is we need to kind of find the maxima and minima of the function x, of the function f of x in the interval that we have found above, right? In the interval negative root 2 going to root 2. So in this interval, we kind of need to find out the maxima or minima of f of x. Now let's see what that was. Now f of x, if you remember, it was 3x minus x cubed, right? This was the function that I had assumed over here. So f of x is 3x minus x cubed. And we are going to use a little bit of calculus over here. So we're just going to find out the maximum minimum value of this. So f prime x will be nothing but 3 minus 3x squared. So the critical points would be x equal to plus or minus 1. And if I take the double derivative of this, I will get minus 6x, right? So therefore it is, and we can also see that f of plus or minus 1 will give us a maxima or minima, right? And essentially we can also see that f of plus or minus root 2 will be plus or minus root 2. And f of plus or minus 1 will be giving us plus or minus 2. So we can really only see that maxima or minima is going to be determined with these critical points. And the endpoints of the interval don't have much of a role to play over here, right? Now we had actually noticed that f double prime of x is minus 6x. So f double prime x is going to be less than 0 at x equals to 1. So therefore f of x has a maxima at x equals to 1. And we can actually see that f double prime x is greater than 0 at x equals to minus 1, right? So therefore f of x has a minima at x equals to minus 1. So if I just put x equal to minus 1, we had f of x is equal to 3x minus x cubed. Now f of x, the maxima of this, what would be the maxima? Maxima would be achieved at x equal to 1, that is 3 minus 1 is equal to 2. So therefore the quantity that we had 3p square q plus 3p square r plus 2q cube plus 2r cube is less than or equal to 2. Its maximum is essentially 2, right? So therefore we have proved the part A of the question. Now for part B, we need to find out the minimum possible value. Or in other words, we kind of had to restrict this so that we get some certain value of k over here, right? And then k would be the smallest possible value of this quantity, right? And how are we going to find k? Well, we've done most of it actually. We just need to find the minima of this, and minima as it was at x equals to minus 1, right? Minus of minus 1 cubed. So that will be equal to negative 3 plus 1. That will be equal to negative 2. So therefore, minimum of this quantity 3p square q plus 3p square r plus 2q cubed plus 2r cubed is negative 2. So it essentially lies between negative 2 and 2. So if I write this in the form of an inequality, I can write 3p square q plus 3p square r plus 2q cube plus 2r cube is less than or equal to 2 but is greater than or equal to minus 2. And when does this happen? Now as we had seen above, this occurs, so the equality occurs at x equals to plus or minus 1. So therefore q plus r at plus or minus 1, right? So yeah, that is the problem. We proved that the minimum value of the inequality, we proved that the maximum value of the inequality is 2, so that the given expression is less than or equal to 2. And then we essentially also find out the minimum value of that quantity, which was what we had to find out in part B. So that would be it for the question. I hope you really enjoyed that, and I hope you really got a good idea of how we can approach certain problems. So calculus in a way does help us in certain situations, but I try to use less calculus over here. But yeah, we need to have an idea of the derivative test at least. Okay, so after that we have certain book suggestions for the ISI CMI. We have challenges and thrills of pre-college mathematics, mathematical circles, excursion mathematics, a test of mathematics at the 10+2 level, elementary number theory by David Burton, pre-calculus by Tarasov, and single variable calculus by I. Maron. And after this we have a little bit of a challenging problem for you, and I want you to find the minimum and the maximum value of the function f of x is x plus y plus 2z with the condition that x square plus y square plus z square is equal to 3. This is a little bit of a challenging problem. Just try to kind of wrap your head around it, see where you go. And if you're able to make any progress on it, or if you're able to solve it, please let me know and I'll definitely respond to you. Well, until then, that's it from me. Thank you very much and bye-bye.
The programs are designed for students who are passionate about mathematics. And they are personalized with one-on-one training, individual evaluation, and remedial sessions. The reason Cheenta students are successful over the last 10 years because they are taught by mathematicians and real Olympiads from leading universities in India, United States, and Europe. Some of our students come back to teach at Cheenta from Oxford, Cambridge, Harvard, MIT, UCLA, ISI, CMI, IITs, TIFR, and IISc. For more information, visit cheenta.com.